This is the Ares Initiative, the coordinated, multinational program to build a permanent human presence on Mars between the year 2075 and year 2100. It begins in low Earth orbit in the summer of July year 2075, with the launch of the first habitat modules, the first freighters, and the first group of 1,500 pioneers. It is neither a single ship nor a single nation's dream. It is a distributed effort that becomes a living, breathing civilization. Over the next 25 years, the pioneers will build cities inside lava tubes and under regolith domes. They will learn to grow food in closed-loop systems. They will invent new laws, new songs, and new prayers, and they will change physically and culturally as their descendants adapt to thin air, lower gravity, and long, red nights. Why Mars? Because it is the closest world with obvious resources: water frozen in the poles and under the regolith, minerals in the basaltic crust, an atmosphere to tinker with, and sunlight to harvest. Earth is where humanity began. Mars is where it chooses to continue. The Ares Initiative is not a single voyage, but a staged, deliberate unfolding. Cargo to orbit, fuel depots at Lagrange points, autonomous construction robots, the first habitats lowered into a lava tube near Tharsis, and then people, engineers, doctors, teachers, children stepping down the ladder into a world that is colder and thinner and redder than the home they left behind. Launch day. In July, year 2075, 3 heavy-lift cargo ships depart from high Earth orbit, each carrying prefabricated habitat rings, radiation shielding blocks, hydroponic modules, and an array of in-situ resource utilization plants designed to pull oxygen from regolith and convert local carbon dioxide and hydrogen into methane and water. 2 crewed transports follow, each with 750 passengers, scientists, construction teams, families, and the medical personnel tasked with the first births off Earth. Within 8 weeks of the first payload arrival, the robotic excavators begin opening a sealed seam into a lava tube near Pavonis Mons. Within 6 months, the crewed teams have installed inflatable habitat modules and regolith berms for shielding. And the first permanent address on Mars is logged. Habitat Alpha, coordinates 16.3 degrees south, 128.1 degrees west. The first million hours are the hardest. Mars gives no quarter. The atmosphere is 0.6% of Earth's at sea level and composed mostly of carbon dioxide. Daytime highs in the equatorial basins may flirt with 20 degrees Celsius, about 68 degrees Fahrenheit, in summer. But nights plunge to minus 90 degrees Celsius, minus 130 degrees Fahrenheit. Solar storms and cosmic rays are a constant threat. Even the thin atmosphere that remains lets in fluxes of ionizing radiation that make outdoor, long-term habitation dangerous without true shielding. The pioneers solve these problems with 3 overlapping strategies. Bury living spaces under regolith layers, use water as a radiation shield where possible, and construct modular magnetic coils around critical habitats to deflect charged particles during solar events. The lava tube becomes not just shelter but cathedral, a cavernous protected world where geotechnical sensors guarantee stability and where gardens hang from cables threaded across basalt walls. Artificial gravity becomes a practical conversation. Mars gravity at the surface is 0.376 grams, 37.6% of Earth gravity. Enough to avoid the worst of microgravity's atrophy, but not enough to stave off long-term bone and cardiovascular changes for multi-generational habitation. The initial solution is localized, rotating centrifuge gyms and rotating agricultural rings whose outer decks spin to produce 0.9 to 1 grams for people spending extended hours there. By year 2085, the larger settlements have engineered permanent spin modules, ring habitats, 200 meters, about 656 feet, across that rotate at under 4 rotations per minute to provide near-Earth gravity. For long shifts, these hybrid habitats are integral to medical strategy. Infants spend much of their day in low-gravity nurseries for developmental reasons, but by age 2 they are gradually introduced to rotating floors so that musculoskeletal development will match the needs of life on the surface. Food systems are a masterclass in engineering and microbiology. The first crops are potatoes, dwarf wheat, soy, leafy greens, and algae tough, fast-growing organisms that tolerate the low pressure, carbon dioxide-rich atmosphere inside sealed greenhouses. Aeroponic towers and multi-tier bioreactors multiply production. Nutrient mist, LED spectrums tuned for human photosynthetic synergy, and closed-loop nutrient recycling transform greywater into fertility. Microbial consortia are curated. Nitrogen-fixing cyanobacteria in a photobioreactor convert atmospheric traces and fertilize living soil. Engineered yeast ferment wastes into protein-rich paste for human consumption. Storage vaults in the initial habitats contain Earth seed banks, spare DNA libraries, and cryopreserved gametes precisely because the pioneers know genetic diversity will be crucial. Population planning is deployed not as authoritarian control but as stewardship. When the Ares Initiative left Earth in year 2075, there were 1,500 souls on the permanent roster. They are a deliberately selected mix: 900 adults with specialized skills, 400 young adults, and 200 children and elders. The command councils on Mars, initially appointed coalitions of mission directors and scientists, implement a set of reproductive guidelines designed to preserve genetic diversity, reduce resource strain, and avoid demographic collapse. Families are encouraged to average between 2 and 3 children. Genetic counselors sequence genomes and provide compatibility advice before conception. Future parents have access to assisted reproductive technologies, cryopreservation, and the now ubiquitous artificial wombs for when conditions or genetics demand. The objective is stable, sustainable growth. By year 2085, the resident population reaches 8,400 through a mix of births and carefully scheduled shipments of settlers and specialists from Earth. By year 2100, that number crosses 29,000, a mix of Martian-born generations, second-wave immigrants, and long-lived Earth expatriates. Disease and the evolution of microbes in a sealed biosphere are a constant watchword. The habitats are closed-loop ecosystems where bacteria multiply thousands of generations in a single human lifetime. The onboard microbiologists create living surveillance networks. Genetic barcodes are embedded in the processed waste systems and air scrubbers so that every microbe's lineage can be logged. When a benign gut strain evolves toward reduced mutualism, genetic therapy and probiotic replacements are deployed. For rare pathogenic outbreaks, a 3-tier response is in place: immediate isolation, targeted phage therapy derived from local bacteriophage banks, and habitat-wide sterilization cycles that use staged ozone and vacuum pulses to avoid wiping out beneficial microbiomes. These episodes teach the colonists humility. The biosphere is living, and their survival depends on constant, modest stewardship. Time and distance between Earth and Mars are short compared to interstellar travel, but that does not mean the psychological distance is trivial. When Earth and Mars are at their closest, a message takes roughly 3 minutes one way. At their furthest, the delay is about 22 minutes one way. For individuals, this is enough to make Earth a distant radio voice rather than an immediate presence. You cannot hold a conversation, you cannot have instantaneous news, and you cannot expect immediate help for complex crises. The Mars-born children grow up with this mediated relationship to Earth. They learn Earth languages, but their cultural references diverge quickly. The first generation on Mars introduces a local argot, compressed phrases and neologisms born of shared tasks: Berm days for regolith work cycles, Simmerlight for the weak afternoon glow beneath the dust haze, Core night for the long hours inside the lava tubes during solar events. By year 2090, the children of Habitat Alpha sing lullabies referencing basalt and the names of early cargo freighters: Pioneer 1, Artemis Freighter, Persephone Lift. The first births on Mars are ceremonial and scientific. On December 12, year 2076, 1 year and 5 months after the initial modules were emplaced, the first Martian-born child arrives, a girl named Maya, after the small, bright moon in a language older than the shipping manifests. Her birth is a quiet testament, under a basalt overhang, with medical staff who had trained on both Earth and simulated Martian analogs. Maya is the first of 372 babies born in the first decade of colonization. Each birth is recorded, each placenta sampled, every newborn entered into longitudinal health studies to understand how a lower gravity, different light spectrum, and altered microbial exposures change human development. Early data show measurable differences in bone mineralization trajectories and slight shifts in circadian rhythms, but cognitive milestones remain within Earth norms, a hopeful sign. Governance evolves with necessity. At first, the Ares Initiative runs a command deck, multinational directors, mission specialists, and a rotating council of elected representatives from among the settlers. By year 2085, as settlements multiply across regions, Tharsis Basin, Valles Marineris Corridor, and the crater-ringed plains near the North Polar region, the system matures into a federated municipal network. Each settlement manages local life support and resource distribution. Core functions like launch windows, heavy lift construction, and long-range in-situ resource utilization plants are coordinated by the Martian Utility Consortium, an independent body that answers to a planetary charter ratified in year 2083. The charter includes rights unusual to Earth's history, enforced limits on extractive exports to prevent Earth-side monopolization, mandatory open-source sharing of critical life support schematics, and a legal recognition of long-term environmental stewardship, an early Martian code of conduct that treats the planet itself as a partner. Industry expands beyond life support. Early on, regolith becomes building material. Sintering robots tile domes with basalt bricks. Three-dimensional printers extrude insulated panels from composite binders. Oxygen plants pull carbon dioxide from the atmosphere and split it into breathable oxygen and carbon for plastics. Metals are mined in small quantities: iron, nickel, titanium, and smelters, powered by concentrated solar arrays, produce the first Martian steel by year 2082. The production of propellant on Mars becomes a turning point. Methane synthesized via the Sabatier reaction using carbon dioxide and hydrogen from local ice allows return stage cargoes and refueling depots in low Mars orbit. By the mid-year 2082, Mars can refuel cargo tugs for Earth-Mars transfers. This practical autonomy is the first hard line between colony and colony caretaker. When Martian-produced propellant begins to reduce dependence on Earth shipments, the colonists find a new confidence that they can survive without the steady hand of orbital logistics. By year 2090, the cultural landscape has changed. 4 generations live concurrently: the elders who remember Earth as a frequent, visceral home, the first-generation planet builders born in their 20s on Mars, the children of those builders who never lived on Earth at all, and the teenagers growing up with digital lives split between a filtered Earth feed and a richly local reality. Religion, art, and myth adapt. The names of shuttles, the colors of solar sails, and the hum of in-situ resource utilization plants become sacred motifs in murals. Festivals arise around the solstice of Mars, a day when the thin sun rises over a distant horizon and the greenhouse lights dim to a shared night. Red Dawn celebrations, where families send tiny glass beads with DNA barcodes back to Earth as tokens, and where elders recite the trajectories of the first freighters across the black. Health and adaptation remain scientific priorities. Long-term exposure to 0.376 grams, 37.6% of Earth gravity, produces subtle but undeniable effects. A slight decrease in average adult height over generations as skeletal architecture optimizes for energy economy. A cardiovascular system that experiences lower orthostatic tolerance yet adapts to sustained lower gravity circulations. An ocular adaptation to the slightly higher ultraviolet index filtered by thinner air plus the reddish visual spectrum of the Martian sky. Local ophthalmologists note that pupils in second-generation children are, on average, slightly larger, and that melanin distribution in the sclera increases modestly in those routinely exposed to exterior light. Evolutionary nudges, not revolutions. The colony's medical consortia run longitudinal registries. By year 2095, they publish a compendium comparing Martian-born physiology to Earth norms, guiding future medical care and informing reproductive advice. Terraforming becomes speculative science and regulated engineering by the late year 2082. Small, targeted interventions begin. Sealed greenhouse arrays release greenhouse gases into localized domed airspaces to study microclimate effects. Subsurface heaters melt pocketed ice to release water vapor into enclosed basins. Genetically tuned photosynthetic microbes are trialed to fix carbon into shallow soils. These efforts are not planetary-scale geoengineering that remains decades, centuries, or longer away, but they are meaningful. By year 2098, there are localized zones with thicker, warmer air under sealed domes, with modestly higher pressure and humidity levels, where plants grow like temperate flora. The Martian Utility Consortium introduces strict permits for any atmospheric experiments. Earth governments watch with a mix of fascination and fear, worried about unintended consequences and the ethics of rewriting another world. The economics of Mars turn from subsidies to trade. Initially, every module and spare part is a cost on Earth's ledger. By year 2088, Martian industry exports rare isotopes, experimental alloys, and data processing services to Earth markets. The colony specializes in certain technologies: low-mass structural composites, sintered from basalt, high-reliability life support components hardened to Martian cycles, and computational models tuned for off-world logistics. Earth-based corporations still supply consumer goods, but an emergent Martian economy begins to favor local production: clothing woven from algae fibers, ceramics fired with regolith, and art made from oxidized iron pigments. Currency becomes both earthly credit and local exchange tokens. By year 2094, the Martian Charter recognizes a dual ledger system that stabilizes trade and ensures that critical life support infrastructure cannot be exported to speculative buyers. Education evolves rapidly. The first schools are technical and survival-oriented do's and don'ts for airlock breaches, how to mend a regolith-sealed dome, the mathematics of heliocentric launches. Quickly, these curricula broaden. Children study Earth history but also Martian geology, Mars's unique ecology, the microbes curated in bioreactors, and a new civic ethos. Maintenance of closed-loop systems is civic duty as much as a job. Language diverges. While English, Mandarin, Spanish, Hindi, Arabic, and other Earth tongues remain taught, a pidgin emerges. Martian Pidgin, a mixture of kernels from many languages and newly coined terms that encapsulate Martian experience. Words like dusk wobble and air hush enter everyday use. By year 2096, the social fabric is tested. Two large dust storms converge near the eastern settlements, named the Aram and the Aeolus storms by meteorologists. These storms last for 19 days, cutting solar power to ground farms, grounding freighters, and threatening life in the outer bermed habitats. The Martian Emergency Response Consortium initiates rolling blackouts, rationed oxygen, and coordinated crop lighting from orbital mirrors tasked with beaming extra photons to critical zones. The storm becomes a crucible. Communities defend their seed banks, engineers jury-rig battery arrays, and families find ways to hold music and story nights by emergency LEDs to maintain morale. 37 people perish, a devastating but comparatively small toll given the level of risk, and the event catalyzes new engineering standards for stormproofing and emergency redundancy. Civic identity consolidates in the aftermath. The survivors establish a memorial, a ring of basalt stones embedded with the names of the lost, placed at Eos Plateau, a shallow ridge overlooking the Tharsis Plains, visible from the largest orbital windows. This ring becomes a pilgrimage site for those preparing for long shifts outside the lava tube walls, and a place where children are brought to learn the cost and fragility of their new life. Rituals form. Every birthday includes a small deposit into a centralized gene diversity fund. Every marriage requires a community planning meeting to ensure housing assignments and education allocations remain fair. Every launch window is met with a public broadcast that mixes telemetry with poetry. The last 5 years of the period, year 2096 to year 2100, are dominated by two twin projects: future-proofing Mars for self-sufficiency and the formal declaration of Martian civic sovereignty. The first is technical. Massive solar concentrator farms are deployed in orbit and at ground stations to provide stable power even during equatorial dust seasons. Water sifting arrays melt and filter subsurface ice into reliable reservoirs. Agricultural bioengineering optimizes crop strains for low-pressure, high carbon dioxide conditions. Most importantly, the Martian Medical Consortia finalize protocols for multi-generational health. Rotational exposure to 1G rings for children and elders, a standard bone density augmentation program using targeted resistance training and timed microgravity exposure, and a genetic care registry that manages inherited risk without coercion. The second is political and symbolic. In year 2098, the Federated Councils convene an open constitutional assembly broadcast to both Mars and Earth. The assembly drafts the Martian Charter of year 2099, a document that recognizes Mars as a semi-autonomous commonwealth dedicated to human flourishing, scientific stewardship, and peaceful expansion. The charter does not abruptly cut diplomatic ties. It sets the terms for trade, migration, and shared scientific enterprise. Earth nations sign as witnesses, not overlords. The charter is ratified on a warm day under the low sun on March 21, year 2099. The ceremony is simple: a reading of names of the first cargo ships, a minute of silence for the pioneers, and a communal planting of the first open-field wheat in a pressurized dome outside New Aries. By the eve of year 2100, the numbers tell a story. The Martian population stands at approximately 29,412 residents across 13 major settlements and dozens of smaller outposts and research nodes. There have been 9,826 births since year 2075 and 1,528 deaths, many due to natural causes, accidents, and those early unforgiving seasons when technology lagged behind necessity. The economy supports regional specializations: mineral smelters in the Tharsis Rim, agritech labs in the Vallis Basin, and orbital fabrication yards in low Mars orbit. The cultural life is rich. Theaters, stage plays that weave Earth myths into Martian landscapes. Painters use iron oxide pigments to capture the diffuse red light. Children learn both Earth history and the names of Mars's ancient valleys. Physically, the people of Mars are changing in small ways. Average adult height has decreased by about 2 to 3%. Among those born and raised there, bodies slightly more compact and muscled differently from Earth peers. Peak bone density curves are lower but more efficiently distributed for Martian life. Circadian hormones shift. Melatonin profiles show adaptations to the longer, colder nights. Genetically, there is no sudden split. Evolution is incremental, but the colony's medical hubs keep detailed genomic libraries to monitor trends and to ensure that any deleterious alleles are managed ethically and with consent. The Martian language, its law, its food, and its art form an emerging identity distinct from Earth but not hostile to it. Children born in year 2099 attend schools where the first modules on Martian civics and environmental ethics are taught. They learn the Martian Charter as a living text and the names of the pioneers as mythic ancestors. They also learn the physics of rockets and the care of closed ecosystems as basic literacy. As the century turns, the Ares Initiative is no longer an experiment but a culture. The lava tube cathedrals hum with life, solar arrays glint like scales on the plains, and the orbital tethers hum quietly with freighter traffic. The colonists have learned to listen to Mars, its subtle quakes, its shifting dust, its whispers of ice below, and to respond with patience and engineering. The story from year 2075 to year 2100 is a testimony to an ethic. Build slowly, share freely, and treat the new world with respect. What happens next is no longer just the domain of engineers. It is now the work of poets, children, citizens. They will decide whether to press for bolder terraforming, whether to open the planet to mass migration, whether to keep certain regions pristine. They will argue about trade routes, about which art forms should be preserved, and about how to remember those who passed in the early years. They will continue to manage microbes as carefully as they manage markets. And on a quiet evening in the new Martian year 2100, under a thin dome of atmosphere warmed slightly by human hands, a child born on Mars looks up at the thin, pale Earth hanging in the black and draws their breath in a world that was just a human lifetime ago, only a dim, red promise. They taste the wheat grown in recycled water and carry in their blood a lineage that includes soil from both planets. Their people have learned to be gardeners of worlds. This is the story of colonizing Mars from year 2075 to year 2100. The launches, the lava tubes, the greenhouses, the births, the deaths, the laws, the storms, and the slow, stubborn growth of a civilization that keeps one foot in memory and one foot searching for dawn. The work continues. The next 25 years will test their engineering and their mercy. The Martians of year 2100 are already planning for the century beyond, for larger cities, for outward settlement of the moons Phobos and Deimos, for the slow, arguable reshaping of an entire planet. But for now, they gather in the lava tubes, they sing, they fix solar arrays, they mend seeds, and they teach their children the names of the ships that first crossed the Black, Pioneer 1, Artemis Freighter, and the freighter lift that carried the first 1,500, whose footsteps quietly became the first Martian footpaths.